6.5, trapezoidal rule. So y'all have the notes for this, but I'm just going to put a couple of the like important formulas up here that we'll need just to refer back to. So for the actual trapezoidal rule, we have T equals h over 2 times y sub 0 plus 2y sub 1 plus 2y sub 2 plus dot 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 plus 2y sub n minus 1 plus y sub n. And if you're given the interval a to b, then h is equal to b minus a over n. These are all in your notes. I'm just rewriting them. Yeah, I like printed you off a nice color copy of my notes and said, y'all need these.
I don't know what those went. Hold on, note the record. Wait.
And n is the number of subintervals that we're breaking it into. Okay, the more subintervals that we use, the better our answer is going to be, because this is basically an approximation tool to help solve stuff. Simpson's rule is S is equal to h over 3 of y sub 0 plus 4y sub 1 plus 2y sub 2 plus 4y sub 3 plus dot 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 plus 2y sub n minus 2 plus 4y sub n minus 1 plus y sub n. And still the same thing if it's from A to B. Can y'all ask Miss Dano to get the credit card and bring it back to me? Thank you. H equals B minus A over N. And N is still the number of subintervals. And so like in the problem, they're going to tell you what N should be equal to. So they're going to tell you how many subintervals to like break it up into. When you do it. These are two formulas that you'll need to know, or like, yeah. All right, so examples. Use the trapezoidal rule with n equal to 4 to approximate the value of the integral. Use the concavity of the function to predict whether the approximation is an overestimate or an underestimate, and then find the integral's exact value to check your answer. So, 2, we have the integral from 0 to 2. Okay, so 0 to 2 is our A to B. Okay, that's the interval that we're using of x squared dx. F of x is equal to x squared, n equals 4. Okay, we're told that in the instructions. Then a is going to be 0 and b is going to be 2. I'm getting that from the integral. All right, so this one says to use the trapezoidal rule, so I'm using this first one. So I need to find h first. So h is equal to b minus a. Come in. Thank you.
I saw the girls, but
Okay, yeah, I didn't, yeah, thank you. 2 minus 0 over 4. So that means that h is equal to 1/2. Do you need a hair tie again? All right, so then the easiest way to do these problems, okay, because you're having to plug stuff in and solve, okay, is that we find each value like of that interval in a table, and then we plug it in. Okay, so we set up, okay, that was great, an x and f of x table. And so we're from 0 to 2, and our intervals are in 1/2 increments. So I'm going to set up x being 0, then 1/2, then 1, then 3/2, then 2. And then I'm going to plug those values for x into the f of x equation, which is x squared. So 0 squared is just 0. 1/2 squared is 1/4. 1 squared is just 1. 3/2 squared is 9/4. And 2 squared is 4.
Oh shoot, stupid. I wrote 8.
8.
Yeah. That's stupid.
So then now we have all the things that we need to actually be able to go in and do our trapezoidal rule. So t equals, it's h over 2, so 1/2 over 2. That was just the setup for the problem, yes. So the first and last piece in your trapezoidal rule are just whatever the number is out of the table. So it's going to be 0 plus, the next thing is 2 times whatever this y value is. So 2 times 1/4 plus 2 times 1 plus 2 times 9/4 plus the last number is 4.
Oh wait, the last number is just
Plus 4, yeah.
Why don't we multiply that one by anything?
Because the rule says not to. So then in reality, I'm multiplying 1/4 times 0's gone. 2 times 1/4 gives me 1/2. 2 times 1 is 2. I'm going to do everything over 2 so that I have a common denominator just to make it easier. So I'm going to write that as 4 over 2 plus 9 over 2 plus 8 over 2, which is then equal to 1/4 times 22 over 2, so 11. And then you can tell me what the decimal is for that. This is 22 over 2. Alright, so that was part A. Part B says to use the concavity of the function to predict whether the approximation is an overestimate or an underestimate. So we need to take the derivative of the function. So what's the derivative of x squared?
1/3 x cubed.
That's the antiderivative.
You're right. 2x.
And the second derivative, because I want concavity. This is greater than 0, so it is an overestimate on the interval 0 to 2. Okay, if we had a bigger interval, it may or may not be, so that's why we want to specify the interval that it's on. And then part C says to find the integral's exact value to check your answer. So the integral from 0 to 2 of x squared dx is equal to what? So now what is my antiderivative? 1/3 x cubed from 0 to 2. So that's going to be 2 cubed is 8 over 3 minus 0. So it's just 8 over 3. And what does that give you as decimal? Okay, so that verifies for you that this is an overestimate. Alright, same thing, but we're going to do it with the trig function instead. We're getting into the fun calculus now. Alright. The integral from 0 to pi of the sine of x dx.
I love it when people don't follow instructions and simple fun. Do we have rosters?
The sass from people is gonna have to go.
I agree.
Like literally, I'm done.
Me too. I want another spring break.
I think we should all just skip school.
Think of these sports rosters.
They're all in that folder, Ariel. If not,
I don't think they're in
just kidding.
Alright. Miss Daniel just left. And we were gonna ask her because she has a list of the round up.
I found it.
Okay, great. All right, so f of x is equal to sine of x. We're told still n is equal to 4. A equals 0, b equals pi. So what is h? What? Yep, so pi minus 0 over 4, so it's just going to be pi over 4. So now I'm going from 0 to pi in intervals of pi over 4. So I'm going to set up my table. So 0, pi over 4. It's going to end up being pi over 2, 3 pi over 4, and pi. These are just so nice because they're all off the unit circle. That's true.
It sucks, but it is it.
Yeah, as long as you don't forget it.
Like something. I remember we took a quiz on unit circle. I don't know. I was pretty sure I knew who won that. Just saying, you know, in case we're keeping any records. Not that I am.
It's okay, Sarah. It's always a competition with him.
There was one loss. One in my record of
That's true, because you definitely win in everything else.
everything. Yeah, exactly. 100%.
I mean, I'm still waiting on that cube to get solved.
Sarah hasn't solved it.
I know, I mean, I did. A lot of times. I've lost track of how many times I've solved it.
Well, you see, I only need to solve it once. I solved the triangle. How many times I solved the triangle?
I don't want to talk about it. Alright, so plug in 0 for sine. So what's the sine of 0?
0.
Sine of pi over 4?
Root 2 over 2.
Sine of pi over 2.
1.
Sine of root 3 over 4. Or root. Sine of 3 pi over 4.
Negative? No, that's because it's sine, so that's still root 2 over 2.
Sine of pi.
0.
Alright, now we can do the problem. Gotta love it when there's like all this set up to be able to solve like one problem.
Yeah, it's just amazing. So.
Alright,
Oh,
so
shoot. That's not good. Oh, crap. I need to go find you. He's a baseball game today at 3. I thought it was at 4 because I was told 4. So that means we have to leave school early at like 2:30.
skipping my class again. I see how it is.
I really hope he has this stuff because I don't think he does. Because I didn't see this text because my mom texted me that he needed to get stuff like this morning. But I didn't wake up until like 7. Oh wait, but I was at 11. 8:11. Never mind. I was in school. That's not helpful. Why would you?
No, you weren't.
Huh?
Not
I
according to
wasn't
the
at
absentee
school.
list.
Yeah, you're right. I was late.
Ariel, there's nowhere to be found.
I was on my
Yes, they
phone.
are. Yes, they are.
You lost someone's eggs. Are you sure Mom didn't get them?
I'm positive.
I'm literally gonna kill
It's not
someone.
funny.
Well, it's not funny. You know what? We're gonna deliver these ones and we'll come back for that little girl who's very mad at us right now because we don't have her Easter eggs. And we said her last name really wrong.
Oh my gosh.
Everyone
It's
just
also really
take-
hot in this cruiser. Just think of a cow.
Miss Marshall and Miss Patton are in great moods. That helps. We'll be back.
Knew I should just not come to school.
If we
I agree. I agree.
Like, you knew your morning was going to start off bad.
I did. I did know that. Thank you. Okay, trapezoidal rule. Trapezoidal rule. Pi over 4 over 2 times, first value is 0, plus 2 times root 2 over 2, plus 2 times 1, plus
Oh, because it's H over
2.
H over 2. It's always H over 2?
Yes.
It's H over N. No. Oh, it's H over 2. Never mind.
Plus 0.
Why do we always have to write this?
What? I'm about to chuck you a hair tie.
Go ahead. I will use it. You will laugh at me this entire time.
I know. That's why I'm not going to.
Mr. Sex.
Even though I have a lot of options on my arm right now.
You'll be stuck with me looking like baby doubles for 3 hours.
You did. You did. A lot. Not a good thing.
I switched it at the end.
I know. I was very glad. And then you can just plug that in your calculator and give me an answer. Alyssa, where's your game today?
Here.
Oh, that's why my dad's taking off work early. He's to come fix the scoreboard, apparently.
Yeah, I didn't work that anymore. Do you know who the Richmond Warhawks are?
Yeah, good.
Are they good?
Yes.
I was gonna say, they're a
Here.
homeschool club team, right?
I don't
Or
know,
at least
but
a
they're
club team.
good. One of their dudes.
I think
okay,
it's Richmond
We
Christian.
played it.
I was gonna say Richmond Warhawks.
We played against.
I think that's their
guys.
name, but yeah.
You know, like no joke. When I tell you that he kicked it, like we were playing on like a national or like a real like MLS soccer field. It was huge. He kicked the ball, like a running start from half field,
And scored.
and like nearly scored. Like if Mason wasn't there, like Mason barely stopped it. Like I mean, I was scared. Like I did not know that was physically possible because he like hit it towards the corner too. It wasn't like a bad kick. It was like going in.
Yeah, people that actually play soccer are actually.
Yeah, I was like, wow. I was like, I could only imagine.
I watched the Grafton soccer game last night, and it was
Yeah, we
really good.
watched a Gloucester game the other day after our game. Then we lost to Portsmouth 8-0, and I was like, oh, this is great. We don't play soccer. We don't actually play soccer. We play some other game.
Sarah, did you get this number?
I want to learn how to play soccer, but I can't practice.
What? Really?
Is that not it?
Are you in radiant? Nope, that doesn't matter. Never mind. That doesn't matter if you're in radiant mode or not. That's not what the book says the answer is. That's why I was like, wait, what? No, radiant doesn't matter.
Cross between the two.
Ah! Got stuck.
Okay, I actually got 1.89.
Sounds great. Alright, so then B, concavity, first derivative of sine of x is
Cosine of x,
second derivative.
sine squared of x.
Nope.
What's this?
No, it's not. It's gonna end up like it was on the bus the other day.
I stood at the right the entire time.
No, you were not.
That's how it was. It's just sine of x.
No.
It's a negative sine of x.
Yes.
Sarah said it.
So negative sine of x is going to be less than 0. So it's an underestimate on the interval 0 to pi. So then we want to find the actual, so the integral from 0 to pi of sine of x dx is equal to what?
Negative cosine x.
From 0 to pi, so negative cosine of pi minus the negative, so plus the cosine of 0. So cosine of pi is what?
Is 2.
What?
Cosine of pi is negative 1, but it's negative. It's a positive, so 1 plus 1 equals 2.
So that just verified it's underestimate. What?
Adios.
Hey, you ready for that test?
Oh, yeah. I knew we had a test. I studied until I couldn't hold my eyes awake anymore. So that was about an hour. I was very distracted. I don't know. I have not been able to focus for my life in the past few days, for the past few weeks. It's been really bad.
It's
Actually.
called senioritis.
I don't know if it will be. It's so
It's
bad.
not a good thing.
It's not.
For me, it didn't kick in until, well, like May.
Well, it's close to me. It's like half of it's really bad.
Most of my class, it kicked in as soon as we got back from senior trip, the first week of March. I held on a lot longer than most of my classmates, but
It's so bad.
I feel like I've had senioritis since like
that needs to be your senior quote.
That's senior.
Can I change it? Okay. I'll think about it.
Oh, what? I'm just writing down given information at the moment. Alright, so these say to use the function values in the following table and the trapezoidal rule with n equals 6 to approximate the integral from 2 to 8 of f of x dx on that table value. So, we know a is equal to 2, b is equal to 8, and that n is equal to 6. So what is h? B minus A over N.
Yeah, I got that like after, so I was like, whoa.
1. Where's my round?
No, you're right. It's 1. Alright, so now we get to plug it all in. Alright, so trapezoidal rule, h over 2, so 1 over 2 times. The first number just gets written down, so 16 plus, then it's 2 times each of these numbers added together, and then add the last one. So plus 2 times 19, plus 2 times 17, plus 2 times 14, plus 2 times 13, plus 2 times 16, plus 20.
Oh my gosh. I cannot see.
You can't see because your hair's in the way or
Yeah,
because it's too small?
What hair is in the way? Okay, thank you.
I think
Now
you
we're
need some
missing
scissors.
4.
What?
We're missing 4. And also, guess whose mom's in the office?
Not mine.
Not
We
mine.
thought it was her, and then it was her car. But Janice is still in the library.
Oh.
I'm so sorry. It's so hot in here.
It's because she's leaving for an appointment.
Yeah. Yeah, that's fine.
No, like actually.
Oh.
Are we sure we got everything from the house?
Well, how do we know if these just didn't get marked off last night or if they didn't go home? Like, how are we supposed to know that?
Because we don't even have contact information.
We're so unorganized. We
I
had
don't
it in
know who
every
these kids
single
are.
name.
Who's missing? Or who do
Geneva, I don't know, it's blind, but I said plume because that's what it looks like.
She's in 6th grade. The kid's in 6th grade.
And she seemed like she didn't have them. Like she never got any, but that doesn't mean anything. And then we're missing someone named Terry Newell, but that's not a kid, that's definitely a parent, but I don't know who that is. And then Gary Chase, I don't know who that is, and Heather Hammond.
Hammond sounds like a familiar last name.
Well, that was,
Didn't you give you guys extra on the yesterday?
yeah, she did, because that was actually one of hers that she had.
That was one of mine well, not my personal one, but.
That's funny.
This is a really big thing.
Oh, and Mr. Law said he was just gonna order
He
3 packs
basically
of
said, he
pizza.
was like, I know she's protective of her card stock, but it'll be fine.
And he said he'll just order some more tomorrow, but we can use what they have up there.
Great.
So we probably need to do that in 6th period, right?
I don't honestly care. I don't know. That's all that was in this folder.
And there's a big possibility they just didn't get marked off.
Everything's marked off of these, so it should be fine. If you don't have them, they're gone.
Yeah, that's the one that. No, that's not.
That's the wrong one, that's the
what
one that we
used.
marked off that we had them.
I don't know. Did y'all solve this down? What'd you get? Great. That's the right answer.
I'm gonna talk to this Hawaii, whatever. She was very offended that I said her last name. And I wanted to be like, look, listen, honey, people say my name wrong all the time. Just get used to it.
Wow.
I think you realize like how many times people say my name wrong. Like it's not just one specific thing. It's like
You should have seen how the lady spelled your name the other day when I told her your name for tennis. I was like, ma'am, just let me
So I've been
just
at
do
this
it.
school for 4 years, right? And the other day, yesterday, matter of fact, I showed up late, right? And she writes my slip and she writes my name, Melchore. Melchor. And I was like, man, like, I've been called so many things in my lifetime, like from the law to Melcar, like from the furthest things you could think of. I've been called Velvet or Velcro. Kate Snyder, she thought my name was Velvet for a little while.
Always a good time.
Yeah.
All right, so these problems, what you're going to notice is that these are identical problems to the trapezoidal rule. They now want you to use Simpson's rule. And then it wants you to like go back and verify like what the value is supposed to be, but you've already done that in the first set of problems. So all you're going to do with these ones is part A. So Simpson's rule. Okay, I'm just going to copy down the table again just so you have it, or we have it to look at. But it's the table from number 2. Right, and h was equal to 1/2 when we did that. So, Simpson's rule is h over 3. The first and last numbers don't have a number in front of them. The other ones alternate 4, 2, 4, 2, 4, 2.
Why?
Don't know. Just is. Just got cold. All right, so S equals h over 3, so 1/2 over 3, times first number, just copy down, plus we do 4 times the second number, so 4 times 1/4, plus then we have 2 times 1, plus 4 times 9/4, plus copy down the last number is 4. So this one conveniently works out so that the 4s all cancel. So you end up with 1/6 times 0 plus 1 plus 2 plus 9 plus 4. So that's 16 over 6. And it's 8 over 3, which is what we had gotten to be the value when we actually took the integral. So in this case, this one was spot on with what the integral value was supposed to be, our part C from number 2. And you're going to find that to be true more often, is that Simpson's rule is going to typically be more accurate than
Why do
trapezoidal.
you have the other rule? It's a little more simple.
We're working on it.
Okay. 18, I'm not going to recopy down the table, but it's the 0 to pi of sine of x dx. I'll try to get this one set up for you at least. So h was pi over 4 for this one. So, okay, refer back to your table in the other one. But, so pi over 4 over 3, okay, because that's what Simpson's rule is, times 0 plus, it would be 4 times root 2 over 2, plus 2 times 1, plus 4 times root 2 over 2, plus 0. So then pi over 12 times 2 root 2 plus 2 plus 2 root 2 pi over 12 times 2 plus 4 root 2. Then you can get that decimal answer is going to be 2.005, which was very, very close to what C in problem 6 said it should be. Should be equal to 2. So this one is basically 2. So you can see it's just going to be a lot more accurate in general. So.